Dear students, good morning to one another, and I hope you are listening well, and I hope you are enjoying these classes, all these remote sensing and GS classes, the way you are attentive to other classes. Here you are enjoying the new. I personally feeling that you are enjoying the knowledge of remote sensing as we discussed this topic, and as we discuss this technology with so many examples what the world is what world has with respect what world has the advancement of this technology and how the world is moving on with the help of this remote sensing technology we discussed in the previous three online sessions as part of first unit syllabus. So far we have discussed what is remote sensing, and also we have discussed what are the basic components of remote sensing, and also we discussed how what is electromagnetic radiation, and also what is electromagnetic spectrum, and how along with electromagnetic spectrum we also discussed about how the EMR is interacting with the atmosphere, and also we discussed and we just started different types of atmospheric interactions of electromagnetic radiation we have discussed in the previous class. Now, apart from while we are moving today's session, I would like to connect the topic what we discussed in the previous session, so that it will be easy, and it will be easy when we are moving as in a continuation part. See here, when we have a look over there in the previous slides, what we discussed. See here in the electromagnetic radiation, of course, you know, and I think there is no need of explanation regarding this electromagnetic radiation once again. And what is this electromagnetic radiation? Already, by this time, you understood what is electromagnetic radiation, from where it comes, what is the source of this electromagnetic radiation. Already you gained the knowledge how it enters into the atmosphere, and also of course, once again, I'd like to give a brief introduction, a brief one or two points about this electromagnetic radiation in this session only. In this session also, see here, electromagnetic radiation is the energy source that is required for the remote sensing sensors. Through that, or as through that energy, or as this is the only energy what sensors can capture, what sensors can required, through which the target of the images will be recorded. From there, the energy will be transported to the processing stations, where the energy will be decoded with the various analytical techniques what we discussed in the earlier sessions. And I hope if any topic or if any situations comes to us, what are the different techniques already we discussed in the second session. It seems there are two types of techniques to develop the satellite images. One is visual image interpretation techniques, and the other one is digital image processing techniques. See here, what is visual image interpretation, what is digital image analysis, that we are going to discuss in the days to come, as per the curriculum designed for you. See here, and today I would like to I would like to discuss about how the electromagnetic radiation is getting interact with atmosphere, and what are the different different what are the different types of types of scattering that is going to be taken place when the CMR interacts with the atmosphere. We have seen that in the previous slides itself. In the previous session, there are two types of I think no need not to discuss about this electromagnetic radiation and electromagnetic spectrum. See here, these words may be different to you, and here the basic what I can say is here, while listening these classes, you may feel that it is very easy, but when you are trying to attempt answers, whenever you got these type of questions, see, you may be if you are not focused on this subject perfectly, or you are not focused this subject 100%, you may not remember to what to write in the examinations, because you may know the concept, but complete terminology is very different, and need not, sometimes the words may not come to your mind. See, for listening it may be easy, and you feel that it is I mean the concept was completely understand, I mean the concept was completely you understood. But by the time when you have a question, write a detailed notes on electromagnetic spectrum, you may not remember. Even you are recollecting, sometimes you may not remember, when if you are not reminding, if you are not going properly through the subject content what we discussed even after the session. What I'm speaking is, after this online session, and try to listen one more time, and try to get the knowledge about this electromagnetic radiation and spectrum, what is happening, so that you may be remembered and you may recollect it easily whenever you come across these type of questions, or whenever you are going to write examinations. See, because all complete terminology of all the subjects is at one side, and this remote sensing technologies is at another side, because you never across these type of words, electromagnetic spectrum and my scattering, relay scattering, and non-selective scattering, nowhere else in all these 4 years of your curriculum. What I'm mentioning is here, try to capture those particular words in your mind with full attentive and with full focused mind, so that these words may be recollected by you whenever in the need, or at the time of need. See your electromagnetic spectrum. See, electromagnetic, there are two words, electro and magnetic. Why these two names? Because the waves, or as the energy, consists to alternative or periodically distributed fields of electric and magnetic field. So it became electromagnetic and spectrum when all the waves and all the wavelengths, when the electromagnetic radiation is made an attempt to made an attempt to keep on a plane sheet, or as to draw a plane sheet with respect to their wavelengths, it constitutes a spectrum, and nothing but where we can observe different types of bands, and you different types of it, we can call it is an a shortwave band, it is called as, we can call it as a radar band, we can call it as infrared rays. That means how it has been divided with respect to the wavelengths. The electromagnetic radiation, once recorded by sensors, it will be recorded with different wavelengths, and every wavelength we can call it as one wave band, and bands may be called with different names: gamma rays, X rays, ultraviolet rays, visible band, infrared, so on. And see, already we discussed in the previous session what is the spectrum and how it constitutes, and here this is about wavelengths and frequencies, about their characteristics. See, now we are here interaction. See, now we are here in the sense, in the previous class we have discussed about this interaction of EMR with atmosphere. See, why the interaction is required and why the EMR is interacting with atmosphere, because the EMR has to pass through the atmosphere itself. How many times? Two times. Why two times? Once the spectrum is, once the sensor is initiated to fulfill a particular purpose, the energy has to hit the target first time, and the same, the once it hit the target, the reflected energy has to go back, has to be recorded by sensors, so that the image will be captured by the sensors, and the same electromagnetic radiation has to send, or has to pass, or as has the radiation has to go to the processing stations. That means after recording of sensors, one more time also we are observing here. But thing is, these two times will be considered, because once the image is captured by the sensors, the same will be transferred to the processing station. So we are concentrating, electromagnetic radiation, how it is hitting target, and how the atmosphere lies at that particular area of the target, what we what for what the sensors are initiated. See, simply here, I want to, already we discussed how the interaction will takes place, because as the EMR is passing through the vacuum of space to, in the name of hitting target, as it is traveling two times, somewhere other way it has to be reflect, it has to interact with the atmosphere, because it has to propagate through the atmosphere itself. And in the meanwhile, or as in the atmosphere, while it is hitting target, as well as the reflected energy being recorded by the sensors, the atmospheric constants influences this EMR, electromagnetic radiation. What may observe, and how may I mean what are the different mechanisms that may take place with respect to the EMR while it is traveling through the atmosphere. Simply, what all the mechanisms that are taking place with respect to electromagnetic radiation while it is propagating from the space to target and the target to sensor. There are two types of phenomena may observed. One is selective scattering, and that's what we discussed in the previous class also, and the other one is non-selective scattering. See here, what is selective scattering here? We discuss. This is also called as molecular scattering. See, once the EMR is being influenced by the molecules of oxygen and nitrogen, where the intensity of EMR, which is supposed to be recorded by sensor, is reducing it because of what the image may be blur, or the image may give haziness to the haziness with respect to the appearance of the image. So when the EMR is being interacted with the molecules, the EMR intensity may not, with perfect intensity, may not be recorded, because of which the image may not give the good resolution. If the EMR is being influenced by the molecules of oxygen and nitrogen whose diameter is at least 0.1 times smaller than the wavelength of electromagnetic radiation, which is reflecting back to the sensors, is called as Rayleigh scattering. And here already that we discussed in the previous class. And another one is my scattering. See, when the EMR is getting scattered, or as when EMR is getting influenced because of the particles, because of the atmosphere constants whose diameter is whose mean diameter from 0.1 to 10 times larger than the wavelength of the EMR, or as larger than the electromagnetic radiation that is reflecting back to the sensors, is called as my scattering. Once again, see here, when the EMR is being influenced by the particles whose diameter is larger, how much? Mean difference minimum 0.1 to 10 times than what? When compared with the wavelength of electromagnetic radiation, which electromagnetic radiation which is reflecting back to the sensors, that is called as my scattering. See here, we already discussed, and it is happening probably most affected at the lower part of lower 4.5 kilometers of atmosphere. Okay. See, and here next to the non-selective scattering, when it is happen, the diameter is larger. When the diameter is larger than the say wavelength, how much larger? 10 times larger than. What are the particles we can expect which are larger almost 10 times than the electromagnetic radiation, or nothing but water vapor, droplets, fog, and ice crystals, etc. This is what about non-selective scattering. See here, and one more thing I would like to explain here. Of course, here you wrote, and you may be visualizing here, non-selective scattering has impact on almost all spectral band. What is spectral band here? See, these are the spectral bands. See here, this is the spectral, this is X-ray band, ultraviolets, and infrareds. All these we can call them as bands, spectral bands. See, see what you wrote and what you are you are visualizing here. Non-selective scattering has impacts on almost all spectral bands. That means when the electromagnetic radiation is being recorded with respect to the wavelengths, almost at all the bands it is being whenever such type of interaction taken place in atmosphere, while the MR is going to be recorded by the sensors, at all the bands the impact will be observed. Understand? See, for suppose you are coming to the college. You are coming to college with a nice, a college bag or something where you keep all the subjects of all subject notebooks. Because of heavy rainfall, your bag dropped into the water, or else bag dropped into the drainage. Almost all books are all books are soaked in the water, and almost all books are spoiled. The impact is considered, and the impact will be in all the subject lectures, in all the subject what I can say is, mean in all the subjects, sessions, or in all the periods of the day, almost, or as in all the subject periods of that particular day, because because of your bag dropped in the water whenever you attended the first period, that you have to give the answer, and your notebook was spoiled. And then even in the same impact will be continued next second hour, third hour, fourth hour, fifth hour, sixth hour, because all the subject all the running notes were all the running notes you kept in that same bag. The bag was dropped into the water because of heavy rainfall, and the impact will be in all the classes you may be encountered. What I'm speaking is here, then the EMR is encountering with this type of atmospheric constituents whose diameter is larger than the 10, and whose diameter is almost 10 times larger than the EMR, the impact will be absorbed in all the bands of electromagnetic spectrum. Hope you understood how it is going to, and why the impact will be in all the bands of electromagnetic spectrum. See here, we are discussing about the interaction of atmosphere. See here, we are discussing about the interaction of EMR, electromagnetic radiation in atmosphere, and we discussed the electromagnetic is being scattered. I am asking you now, can you observe only scattering, or is there anything else? Is anything else that can be taken place in the atmosphere to that reflected energy, or as to the emitted energy, or as to the incident energy? What is incident energy? The amount of energy that is hitting target is called as incident energy. Emitted energy, in the sense, the amount of energy that is reflecting back, is called as emitted energy, emitted from the target. Two types of energies we are here in this particular point. One is emitted energy, another one is incident energy. Incident energy is the amount of energy that hits the target of interest, and the second one is emitted energy. After incident, okay, after incident energy, the amount of energy that is going back is called as reflected energy. Now here I'm asking you here one, I would like to ponder one particular point. As the title is interaction with atmosphere, is the scattering only the consequences you can observe when EMR is passing from the through the atmosphere? If you speak only scattering, you are certainly wrong, or else you are certainly forgot about the absorption. One more phenomena may be observed in the atmosphere apart from the scattering, that is nothing but absorption. See here, in remote sensing techniques, we have a work, and we are completely dependent on the reflected energy. Understand? See, reflect, see, somehow you are doing business. For suppose you are doing business with an investment of maybe some X amount, maybe for with an investment of 1 lakh. The survival of business depends on the amount of money what you are gaining. Am I right or not? If the 1 lakh is consuming in the business itself, you are not in a good success, not a successful businessman. Understand? If you are if you are spending 1 lakh rupees, the survival and the continuation of your business depends on how much you are earning, how much you are getting back, the fruits of your investment. The survival, the continuation of business depends on the expectancy of the income. In the same way here, the amount of energy that hitting target, the quality of image depends on the reflected energy. The quality of image depends on the emitting energy, or as emitted energy. The quality of image depends on the, or as the resolution of the image is depends on the reflected energy. When the and it is reflecting, when the energy is reflecting, we observe there might be a possibility of scattering. If the energy is not reflecting, then what happens? There also image may not give good resolution. If it is not reflecting, what you can expect? Simply the energy is being absorbed by the target. In the first case, the energy is scattering. Here, see here in this particular slide, the energy is being scattered. but actually this energy has to be recorded by the sensor. As the energy is not recording by the sensors, the image will give blurriness. See, in the second instance, image, the reflected energy, the quantity of energy which has to go back to the space or to the sensors is reducing because of the absorption of the energy by the target or is by the atmosphere. Understand? See, have a look over here. See, absorption here, two, I mean, almost three areas you are observing. See here, absorption may takes place in atmosphere, and absorption may takes place even at the target itself. In the first case, the light is redirecting, whereas the EMR is redirecting. And here in the second case, the EMR is absorbing. By what? That's what we are going to discuss. Apart from the scattering of the light, one more phenomena you may be observed, that is nothing but absorption. See, absorption means in contrast, it is just contrast to scatter. Scatter in the sense it is being diverted into the different directions. Absorbing in the sense it is being consumed into one particular position, into one particular point, into one particular phenomena is called as absorption with respect to this particular incident. Understand? See here, in contrast to scatter, atmosphere absorption results in effective loss of energy to atmosphere constituents. And here, the most considered absorbers of solar radiation are CMR are water vapors, carbon dioxide, and ozone. Because these gases tend to absorb electromagnetic energy in specific wavelength bands, they strongly remote. See here, they strongly in the sense here, because of the absorption of because these gases tend to absorb, okay, radiation which is supposed to be recorded in the sensors is being absorbed. Because of this, the image may give blurriness, and the resolution of image may be different or may be reduced. And here, about, see, we have completed. So, and we I hope you understood how the atmosphere shows its impact on electromagnetic radiation. Now here, the other topic is interaction of EMR with earth surface. See here, interaction of EMR with earth surface. In the previous, what happening in the atmosphere we discussed. Now in the second instance, how the energy is interacting with the earth surface. Now the question is interaction of EMR with atmosphere and earth surfaces. See here, when you observe here, incident energy. What is this incident energy? Simply we discussed just bit before, just before now only. What is incident energy? The amount of energy that is hitting the target is called as incident energy. The amount of energy that is reflecting back to the sensors is called as reflected energy. Hope you understood. See, here we are observing four types of energies, and you know that when the incident energy is hitting the target, some amount may be reflected and some may be absorbed, some may be transmitted. It depends on the properties of the target. It depends on the characteristic features of the target. It fully depends on the quality, or else it depends on the what I can say is depends on the quality, depends on the nature of the target. Understand? Hope you understood. See here, incident energy is, once the incident energy is hitting the target, it has to be reflected back, and that reflected energy holds the image of this particular water body or as this particular target. If the reflected energy is being interacted, being influenced by the atmosphere constituents, we just named it as selective scattering, non-selective scattering, even in the because of the absorption also. Now what happening here? Simply how it is interacting. Hope with this diagram you understood what may happen. See here, some amount of energy is absorbing and some amount of energy is transmitting from this point to another, this object to another object. how the energy is transmitting. You know how the energy will be transmitting. For suppose, see here incident energy, the absorbance is over, and transmittance from one transmittance from here to the transmission, because we may not expect this transmitted transmission energy for all the objects, because especially for earth we may not have this transmitted energy, because earth is opaque in nature. Earth may, the transmitted energy may not be possible for the objects like earth, because from the air, see, the energy may not transmit from earth to other areas, or else, because we can simply one point, as the earth is opaque in nature, the energy may not transmit through the earth surface. The topic is energy interaction with earth surface. Now we'll see here, when electromagnetic energy is incident at any part of earth surface, we'll observe three fundamental possible interactions. One is, oh, that's whatever I discussed now, again I wrote here, again you are visualizing in this PPT. One is incident, one is reflected energy. This is represented figure for an element volume of water body. See, we have taken the example of water body. There we represented three types of energy. See here you are observing one equation, EI lambda. See, lambda, we are just the energies representing with respect to the wavelengths here. See here, EI lambda is called incident energy, is equal to reflected, equal to absorbance, equal to transmits. See, that means what I can say is, first suppose, if you, um, your father has given 100 rupees to you, somehow, as your friend, if your friend has given 100 rupees to you, see, the amount of energy that is you are giving back to your friend is reflected. The amount of money that you are spending is absorbance. The amount of money that you are transmitting to one of the other friend is transmittance. Hope you understood. See, whatever you are spending, that must be equal to the money what you got from your friend. Simply, electromagnetic I see here incident energy in the sense, the energy that is propagates through the vacuum of space and hits the target, that is incident energy. And once the energy hit the target, three types of energy maybe three type, it may split into three categories. One is reflectance, absorbance, and the last one is transmittance. See here, AA represents absorbed energy, ET represents transmitted energy. And here, lambda, why we representing lambda with all energy components being a function of wavelength lambda. Here the completely all when we have a look over there in electromagnetic spectrum, all the bands are categorized with respect to the wave. So here, with all energy components being a function of wavelength lambda, we just kept we are discussing with respect to the lambda. See, the above equation is an energy balance equation. See, your energy is getting balanced here. Incident energy is equal, has to be, or else we can divide it into reflected, absorbance, transmittance. That's what you are visualizing here. And the other one is, see here, the reflected, here you are observing one more particular word, you are encountering one particular word, that is nothing but spectral reflectance. Keep in mind, this spectral reflectance may come across in the second unit, and it may come across even in the last units. You must know what is spectral reflectance. Before that, here, here, see, the reflectance characteristics of Earth surface features will be quantified by measuring the portion of incident energy which is reflected. See here, the point, the point, when you have a look on that particular point, see how the reflectance features of Earth surface is being quantified, means with respect to the portion of energy that is reflecting. What is the title here? See here, in energy interaction with Earth surface. See how I can understand the characteristic of one particular object on the Earth while it is being recorded by the sensor. See, if with your camera, if you are trying to capture the image of your friend, or else if you are trying to capture the image of one particular object that is damaged, for suppose a drafter, we discussed in the first session with an example of drafter. You just taken an image of a drafter that is damaged, or else, of course, let us assuming that you are taking an image of nice drafter, or as new drafter. How you can understand it is in a nice and new drafter? Because by the quality is reflecting in the image. Am I right or not? See, the quality of diopter is representing in the image what you are captured with your mobile phone. That means how it is captured, because the energy traveled from the drafter to cam and cam to drafter. Hope you understood. The same way, the earth feature characteristics can be defined with respect to the reflected energy of EMR. That's what you wrote here. See here, the reflectance characteristics of earth surface features. Why you mentioned here earth surface features? The topic is earth surfaces, interaction of energy interaction with earth surface. That's what you are mentioned here. The reflectance characteristics of earth surface feature, earth surface will be quantified with by measuring the portion of incident energy which is reflected. This is always that always the all the measurements, okay, see, will be measured. See, this is, see, in the second point, this is measured as a function of wavelength and it is called as spectral reflectance. What is spectral reflectance? Measuring of wavelength, or as measuring of, see, measuring of reflected energy by the constant with respect to the wavelength is called as spectral reflectance. Sensitive line is there. That's what I wrote one more definition also here. Spectral reflectance can be defined as a measurement of energy, can be defined as it is a measurement of energy, a surface that reflects at a specific wavelength. One more time, have a look over there. Spectral reflectance can be defined as it is a measurement of energy as a percent. It is a measurement of energy, a surface on the earth that reflects at specific wavelength is called as spectral reflectance. One more time, have a look over there. Spectral reflectance can be defined as it is a measurement of energy. It is a measurement of energy, a surface reflects at specific wavelength. See, what is the spectral reflectance? See, when you have a look over the electromagnetic spectrum, see here, spectral reflectance is getting is measuring here with respect to wavelength. Understand what is spectral reflectance here? How the energy is reflecting here in this particular band at X band. That means, thus here keep in mind how the energy is being measured for a surface, or as the energy that is reflected by a surface, or as by an objective is measuring with respect to wavelength is called as electromagnetic spectrum. Malla once again. See here, have a mind. See, have a focused mind here. Electromagnetic radiation spectral reflectance can be defined as it is a measurement of energy. Measurement of energy of what? A surface that reflects at a specific wavelength. Specific wavelength in the sense what it means here, specific wavelength. This is the specific wavelength of electromagnetic spectrum. See, from 10 power, see, for suppose if you have a 10 power minus 11 to 10 power minus 3, you just mentioned here gamma rays. Reflect, see, measurement of energy of a surface, okay, at its specific at specific wavelength. Here, if the energy is measuring here, that gives the what that can gives the information about the spectral reflectance of the object that is stored at this particular band. That is called as spectral reflectance. See here, spectrum means the when all the wavelengths which are emitted by the electromagnetic, which are recorded by electromagnetic radiation, that are being taken into a plane sheet, it gives the spectrum. See, simple electromagnetic, see, spectral reflectance can be defined as it is a measurement of energy, a surface reflects at a specific wavelength, that is called as spectral reflectancy. See here, it is mathematically defined as R lambda equal ER lambda by AI lambda, that is equal to energy of wavelength lambda reflected from the object, by energy of wavelength incident upon the object into 100. How we can get it? See how it is lambda mathematically defined as, see, r lambda equal, see here, r in the sense spectral reflectance at one particular, what one particular wavelength can we can get this spectral reflectance of one particular spectral band, either maybe X band or gamma band or other ultraviolet band, can be measured by what? See, spectral reflectance by incident energy, which is equal to energy of wavelength reflected from the object by energy of wavelength with respect to lambda incident upon the object into 100. See here that by with this formula, this is the empirical formula here. It is an empirical formula. See, we can't go much explanation about here. See here, this is the empirical formula in the sense here. We may not go to why happens and how it comes. See here, after many experiments, as one particular equation will be given. Based on that equation we'll move forward, and we are not going particularly how it comes and why it comes. See, whenever you comes to understand, whenever you want to measure the spectral reflectance of one particular spectral band for one particular object, it can be quantified with this formula. This formula has to be understand has to be reminded, and has to be has to be what I can say is, this formula you must remember as an when you are writing examinations, because this is an empirical formula. We are not going to solve here, and there is no meaning of solving here when the spectral reflectance can be measured with this following formula. That is the only way you must remember as part of the curriculum that is design. We are not going to discuss, and we are not going to explain how the formula is came to existence, because if you focus how this formula came to existence, the syllabus period that is constituted for this curriculum may not be suitable, because the time length may be different. Whenever you are going through particularly into this particular spectral reflectance in a more elaborated manner, there you must there you must have the analytical knowledge how this formula comes to existence. See here, that's what about this interaction of interaction of electromagnetic radiation. It's earth surface. See, one more time I would like to focus on this earth surface. See here, there are the incident energy can be can be divided, or as the incident energy can be split into the three types of energy. One is reflected energy, the other one is absorbed energy, third one is transmitted energy. See here, this is the energy balance equation. The energy whatever hitting the target has to go into three types of three has to go through three categories. One is some portion has to be reflected, and some portion has it depends the all these three types of it depends on the properties of properties of the target. The instant energy may be reflected, as may be absorbed, may be transmitted, but whatever the action taking place, that has to be equal to the instant energy. The portions of all the different energies has to be equal to the instant energy, the portion of the instant energy. That's why you are mentioned here, the formula is instant energy. Why we kept lambda? It's because we are measuring energy with respect to the wavelengths. Those wavelengths are constitute electromagnetic spectrum. See here, in the one more word is spectral reflectance. It's here in the band how the surface is reflecting. For suppose, see here, when we have a look over here in electromagnetic spectrum, see, by understanding this, the reflectance, by understanding this band appearance, you can understand the how the image will be. Understand spectral reflectance, how the spectrum band is reflecting, what it gives, whether the band can give good image or not, whether this band holds good resolution of image or not. Somehow, by seeing an objective, certain objectives, he can come to conclusion this is good and it is not good. By seeing that drafter, you can understand this is in a good condition. Even you may not start using of the drafter. By seeing it, you can understand it is portable. In the same way, based on the reflectance of this band, can gives the information how the image of the captured electromagnetic, how the image of the target that is captured at this particular band. Spectral reflectance is nothing but measuring of energy at one particular spectral band with respect to wavelength is spectral reflectance. Nothing but here how the energy is, what I can record it with respect to wavelength, it gives the information about the spectral reflectance, and it can be understand, and get the spectral reflectance can get by applying the formula where we have seen, in the name of empirical formula, by applying or else simply by adapting the formula, that is nothing but can be defined as er lambda by a lambda, which is equal to energy of wavelength of incident upon the object into 100, where r is expressed as percentage. See here, the last point is experience has shown that many earth surface features of interest can be identified, mapped and studied on the basis of their spectral characteristics. That's what I said, that all the earth surface, almost most of the objects on the earth can be understand can be measured with respect to the spectral reflectance of spectral reflectance at particular portion of the wave bands or as wavelengths. Understand, hope you understand. The spectral reflectance of different objects on the earth surface can be understand by seeing, by visualizing the electromagnetic spectrum. Hope you understood how the EMR is interacting Earth surface. The instant energy, what is instant energy, you understood. What is reflected energy, you understood. What is, hope you, what is, you have a, you may get in a point, or else you may have content. You may have the, you may hold a handful of experience with these slides, how the instant is being scattered, and how the energy is being scattered, and how the energy is being absorbed, how the instant energy is being redirected, being categorized into different types as reflectance, absorbance, and transmittance. If you have any doubts, you can contact me in the domain whatever you feel comfort. Thank you, and maybe in the next session we'll discuss about the followed topic as part of your curriculum. Thank you. Thanks a lot.